Hello, everyone, and welcome to our presentation on the quantitative results chapter. Just before we get started with the presentation, I'd like to present this information in case you're interested in additional support outside of this webinar. So we do provide assistance with all aspects of the dissertation. So if you are interested in more one-on-one support outside of this webinar, you can use the information that you see here to contact us and learn more about the types of assistance that we're able to provide. And just to give an overview of what we will be discussing today, so this presentation is on the quantitative results chapter. So we're only going to be covering components of the quantitative results chapter today. We won't be covering aspects of qualitative or mixed methods. We do have other webinars dedicated to qualitative results. So if you're interested in that topic, you can check out that specific webinar. So first, we'll talk about the purpose of the results chapter and why it's important to the dissertation. And then we'll spend the majority of the presentation going over the different components of the results chapter. So starting with the introduction, we'll talk about data collection and preparation, the demographics and descriptive statistics, and we'll talk about assumptions, testing, and the analyses for the research questions, and then the summary. And then at the end of the presentation, we'll have an opportunity for you to ask questions. So if you do have any questions, you can put those into the questions section. And at the end of the presentation, any questions that aren't answered over the course of the presentation, I'll do my best to answer your questions. So first, let's talk about the purpose of the results chapter. So the results chapter is designed to present the data and the analyses that you conducted to answer your research questions and hypotheses. So the earlier chapters of the dissertation are geared towards establishing why your research needs to be conducted and how your research is going to be conducted. So in your introduction, literature review and methodology chapters, you kind of establish the why and the how of your research. Once you get to the results chapter, you're finally going to explain what the results of your research are. So you're going to be presenting the findings that you're going to be using to answer those research questions that you set out in the beginning of your dissertation. And so by the end of the results chapter, you should have a clear answer to each research question hypothesis that you laid out in your dissertation. So if you have 5 research questions, by the end of your results chapter, you should have an answer to each of those 5 research questions. And so in your results chapter, you'll want to provide clear statements that answer those questions or hypotheses. But you want to save interpretation beyond that for your discussion chapters. So any discussion of what the findings mean in relation to the literature or the implications for future research or anything like that should be saved for your discussion chapter. In your results chapter, you really just want to present the analyses that you conducted and the answers to the research questions, and that's it. And while in this presentation, we will be discussing the sections and content that is typically included in the results chapter based on our experience with many different schools, it is important to follow your specific school or degree program's guidelines for the results chapter. So your school may require more sections. They may require the sections to be organized a little differently than how we present them here. So you do want to defer to the specific requirements for your school or your degree program when you're constructing your chapter. So now let's start talking about the components of the chapter. And like other chapters of the dissertation, you usually start with a brief introduction where you reorient your reader to the purpose of your study, your research questions, and you go over the contents of the chapter. So you can just restate your problem or purpose statement either verbatim or have an abbreviated version of your problem and purpose statement to reorient the reader to that. Then you want to restate your research questions and hypotheses. And it's important to note that throughout your dissertation, the wording of your research questions and hypotheses should remain the same. So every time your research questions and hypotheses appear in your document, they should be presented the exact same way in the exact same wording each time. And then you can just outline the contents of the results chapter, and this can be just as simple as listing out the different section headings that will appear in the chapter. Now, the first thing you'll probably want to go over in the chapter is information about the data collection and preparation. So here, you're going to want to summarize the data collection procedures that you followed, and importantly, note any changes from your originally proposed procedures. So in your proposal phase, you may have proposed a certain set of data collection procedures that you intended to follow for your study. But it may be the case that by the time you get to your results chapter, that those procedures may have changed in some way. So maybe you weren't able to do the data collection exactly the same way that you originally set out to do it. Maybe you had to recruit participants a different way because your originally proposed recruitment procedures didn't work out, or you had to recruit from a different population or use a different method or something like that. Or maybe you had to use a different instrument. Whatever the case may be, if any data collection procedures changed from when you originally proposed them in your methodology chapter to when you actually collected the data, you want to make sure that you explain what those changes were. So schools will have different ways that they want you to go about doing this. Sometimes schools will actually want you to go back to your methodology chapter and change the methodology chapter to reflect the actual data collection procedures that you were able to conduct. But sometimes schools will want you to keep your methodology chapter the same, but instead explain any changes that you had to make to the data collection procedures in your results chapter. So again, make sure you refer to your school's guidelines for how specifically they want you to discuss any changes in your data collection procedures. But you do want to make sure that they are discussed somewhere. One thing that you'll want to talk about in this section is response rate and attrition. So, and for our purposes, we'll just be assuming you're conducting a simple survey study. So you may want to discuss things like how many total responses did you receive for your study? So if you're doing something like an online survey, how many total people accessed or took the online survey? And then did you have to remove any people or exclude any responses for any reason? And if so, how many? So for instance, maybe you had to exclude some responses because they didn't meet your eligibility criteria for your study. Or maybe you had to exclude some responses because they were missing too much data. So there could be any number of reasons why you may need to exclude some participants, and you'll want to report that in this section. After you talk about that, you'll want to state what your final total sample size for the analysis is. And then, if necessary, you may need to conduct a post-hoc power analysis if your target sample size was not met. And different schools will have different requirements for when they will require a post-hoc power analysis. Sometimes it's if you don't meet the sample size. Sometimes it's if you get any non-significant results. But you may need to conduct a post-hoc power analysis. And here you may also need to discuss preliminary data preparation steps. So this can involve things such as checking data for accuracy, how you're handling missing data, checking for things like outliers, and also any coding or recoding that needs to be done for your data in order to compute the variables used in your analysis. So checking the data for accuracy can be important, especially if you're working with something like paper and pencil survey data that you had to manually enter into an electronic format. you want to make sure you check those values to make sure there aren't any mistakes in the data entry. One thing that you'll likely need to talk about is how you're going to handle missing data. Especially if you're doing something like an online survey, it's very likely that you will have missing data of some kind. So for whatever reason, people may not complete your survey all the way to the end. They may skip some questions. You're probably going to have some missing data, and you're going to need a plan for how you're going to handle that. So are you just going to exclude all participants who are missing any data at all and only include participants who had complete data? Or are you going to try to include participants who are missing some data? And if so, how are you going to handle those missing values? Are you going to try to replace or impute them in some way or handle those missing values in some other way? So you want to lay out all of the steps and procedures for how you're going to handle that. And then for coding or recoding of data, if you have something like a survey instrument where, for instance, you might have multiple items that make up a certain variable or construct, like maybe you have a 10-item instrument that measures self-esteem, how are you going to score that instrument to compute your self-esteem variable? Are there any items in there that maybe need to be reverse coded, or do they need to be coded in some special way in order to compute the variables that you need? Do any demographic or control variables need to be recoded in some way? So you'll want to describe that process here. And so now I'll just show a couple of examples of how this write-up of the data collection and data preparation might look. So in this excerpt, we start by saying we have an initial total of survey responses that we received. Then we state how we excluded some participants who did not complete a large portion of the survey. Then we state our final total sample size. And then we discuss how we dealt with missing responses. So in this case, we say that we're going to impute the missing responses using a regression imputation. Here's another example of how this might look with just a little bit more detail. So we have information about the data collection. Again, we say how many total participants accessed the survey. Then we go into details about any participants that we needed to exclude. So participants who didn't agree to the informed consent, participants who were missing some data, participants who didn't meet our exclusion or inclusion criteria. And then we state what our final total sample size was here at the end. And here's just an excerpt of what a write-up for a post-hoc power analysis might be. So if you need to conduct a post-hoc power analysis, you would say what statistical analyses you conducted the post-hoc power analysis for. You'd state what your sample size was for those analyses. And then you would state what level of statistical power you achieved for those analyses given the sample size. So next we'll talk about the descriptive statistics section. So after you've gone through all your data preparation, now you can talk about preliminary descriptive statistics that you run on your variables. And so here you want to present your descriptive statistics, which may include frequencies and percentages for categorical variables. So things like gender and ethnicity may be categorical variables. And then statistics like means and standard deviations for continuous variables. So examples of those might be someone's age in years, or grade point average might be a continuous variable. If possible, you may want to compare your demographic characteristics in your sample to the population. So if you have population statistics for certain demographic characteristics, you may want to discuss how your sample compares to that. So for instance, maybe you're looking at a population and what the gender breakdown is in that population. Maybe you're dealing with a population that has more females than males, or has a certain percentage of females compared to males. You can compare that to the percentage of females and males that you have in your sample to see if that is a reflection of the population or not. And then if you have things like survey instruments that use multiple items, you may want to present reliability coefficients for those sets of items. So something like Cronbach's alpha for applicable measures. And so here's an example of how you might present some descriptive statistics for some demographic information. So here we have frequencies and percentages for some categorical variables. And one thing to keep in mind when you present tables in your results chapter is, first, you want to make sure that you always refer to your table in the text. So you never want to just present a table without a reference to the table in the text. So you see here, we see our demographic characteristics are presented in table 1. So if we present this table, we want to make sure it's referred to somewhere in the narrative. And also, you want to make sure that the table appears in proximity to where it is referenced in the narrative. Specifically, you probably want that table to appear in the paragraph or below the paragraph where it is referenced. So for instance, you don't want to make a reference to table 1 and then table 1 doesn't appear until 5 pages later. Or you don't want to present table 1 and then don't make a reference to it until 5 or 10 pages later. So your reference to the table should appear close to where the table appears in the document. Here's an example of a table for some descriptive statistics for continuous variables. So you see here we have mean and standard deviation as well as minimum and maximum values. And then here's an example of a table for some Cronbach's alpha coefficients. So we have different measures that we conducted reliability analysis for, and we present the number of items in each of those measures as well as the Cronbach's alpha reliability coefficient. So now let's talk about assumptions testing. So for each analysis that you do to answer your research questions, that analysis will likely have statistical assumptions that need to be tested so that we can ensure that we can interpret the results of those analyses correctly and accurately. So for instance, if you're doing something like a t-test or an ANOVA, you may have to test assumptions such as normality and homogeneity of variance. And so you want to describe in detail all of your assumptions testing and what the results of those assumptions tests are. So for each analysis, you want to list out the assumptions that need to be tested. You want to explain how each assumption is tested. So for instance, if you need to test normality, how exactly are you testing that assumption? Are you using something like a Shapiro-Wilk test? Or are you looking at something like a normal probability plot or a histogram? Or are you looking at skewness and kurtosis values? Or are you using a combination of those things? You'll want to state specifically how the assumption is going to be tested or how you did test the assumption. You want to say what the result of the assumptions test was. So, however you decided to test for normality, you want to be able to interpret that test. So for instance, if it was a histogram, did the histogram appear to have a normal distribution? If you're doing a Shapiro-Wilk test, was the Shapiro-Wilk test significant or not? you want to make a clear statement about whether the assumption was met or not. So again, for your normality test, you not only want to interpret the result of that test, but make sure you state, based on the result of that test, was normality met or was normality not met? And then if the assumption was not met, you will want to discuss any action that you took to account for the fact that the assumption was not met. So if you conduct your analysis and you find out the assumption of normality is violated, then you'll want to talk about what you're going to do about that. So are you going to try to transform the data so that the data are normal? Or are you going to run an alternative test like a non-parametric test, which doesn't require the normality assumption? So you'll want to state what you're going to do, or what you did rather, if that assumption is not met. And it's important to note that this can be organized a couple of different ways. So assumptions could be presented in their own dedicated section before you discuss the results of your analyses. So you can just kind of discuss all of the assumptions at once and get them out of the way before you get into the results of your research questions. Or you can just present the assumptions test for each analysis you're doing alongside each analysis. So you might have a section for your research question 1, the assumptions test for that research question, then the results of the analysis for that research question, and so on, repeating that for each research question that you have. So let's take a look at some examples of how you might write up the results for assumptions tests. And here you have an example of a normal PP plot, which would be a test for normality. And so we say here in our narrative that we are testing normality by examining this normal PP plot. We interpret that plot by saying the data did not significantly deviate from the normal line. And we say that the assumption of normality was met. And we present our normal PP plot here in a figure. Now here's an example of an excerpt where we discuss some assumptions. And in this case, we have an example where one of our assumptions was not met. So here in this highlighted portion, we say that we're doing this test for outliers and that there was an observation that we detected as an outlier. And then we make a statement about what we did about that. So in this case, we say that we are excluding this observation from the analysis. So we're excluding that outlier. So now the analysis of the research questions is really the main part of the results chapter, where you talk about the analysis for each research question and what the result was. So here you want to organize this section by research question and hypothesis. So if you have 5 research questions, then you want to just go ahead and start with research question 1, and then do research question 2, and so on. You don't really want to jump around and do things out of order, like start with research question 2, then jump to research question 5, and then go back to research question 1. You want everything to be in a very organized and logical order based on the order of your research questions. And much like your data collection procedures, if there are any changes from your originally proposed data analysis procedures, you want to note what those changes were. So again, for one reason or another, maybe the analysis you originally planned to do, you weren't able to do. And that could coincide with changes in your data collection plan. Maybe you weren't able to collect the exact data that you originally planned to, so that may have affected the type of analysis that you're able to do. So if your analysis plan changed from what you originally proposed, you will want to explain that change and provide justification for the new analysis that you are doing instead. Now, for each analysis, you're going to want to clearly identify the variables that you're using. So if you're doing something like a t-test or an ANOVA, you might identify what your independent and dependent variables are. If you're doing something like a regression, you'll want to identify your predictor variables, your criterion variable, any covariate or control variables that you're using. You'll want to report the appropriate statistics that are associated with each test. So it include things like your significance or p-values, effect sizes that are appropriate for those tests. So for a t-test, you might report something like Cohen's d. For a regression, you might report your r-squared value. And you may also want to report things like confidence intervals as well for, for instance, for something like a regression coefficient. And then if your analysis requires any post-hoc testing, like for instance, if you're doing an ANOVA and your ANOVA was significant and you need to do pairwise comparisons to determine which groups were significantly different from each other, then you'll want to report the results of those post-hoc tests as well. And it's very important that for each research question and hypothesis, you include a very clear statement that addresses that hypothesis or answers that research question. So it's likely that you'll have your hypotheses written out in the null and alternative format, in which case you can make a statement about those hypotheses, specifically the null hypothesis, say whether the null hypothesis was rejected, if your result was statistically significant, or if the null hypothesis was not rejected, or if you failed to reject the null hypothesis, if your result was not statistically significant. So now let's take a look at some examples of how you might write up the results of different kinds of tests. So here we have an example with a t-test. So we start by saying what test we're doing, and we're identifying both our independent and our dependent variables for the test. We present the statistics associated with that t-test. So for our t-test, we want to present our t-value along with the degrees of freedom for that test in parentheses, our p-value or significance level, and then we have an effect size measure here for Cohen's d. We state that the test was not significant because our p-value here was greater than 0.05. Make an interpretation of that test. It's not significant, so there were no differences between the groups. And we make a clear statement for a hypothesis saying the null hypothesis was not rejected. And you may also have a table displaying relevant statistics for the test. So for something like a t-test, maybe you have a table displaying the means for each of the groups that you're comparing, like we see here. Now here's an example, again, for a t-test, but this time we have a t-test that turned out to be significant. Again, we start by saying what test we're conducting, we identify our independent and dependent variables. We say the results of our test were significant. Again, we present our statistics here. This time our p-value is less than 0.05. This indicates that there are differences between the groups. And here we have a statement for our hypothesis. Since our result was significant, our null hypothesis was rejected. And again, we have a table here displaying the means for the groups. Now here's an example of how you might write up the results for an analysis of variance or an ANOVA. Again, we say what analysis we're conducting, and we identify our independent and dependent variables for the analysis. We present the statistics for our ANOVA. In this case, for an ANOVA, you also want to report your test statistic, which in this case is the F, as well as the degrees of freedom. For the ANOVA, you'll always have 2 degrees of freedom instead of just 1. We have the first degrees of freedom in the parentheses, which is the numerator degrees of freedom. And then the second value is the denominator or error degrees of freedom. And we present our p-value or significance value. In this case, it is greater than 0.05, so our results are not significant, indicating that there are not differences between the groups. And we make a statement about our hypothesis. Our null hypothesis was not rejected. And again, here you might present a table with the means of the groups that you're comparing with the ANOVA. And here's an example shifting more towards a correlation analysis. So here we did some Pearson correlations. And here we actually restate our research question. We say we're conducting Pearson correlations and identify the variables that we're using in those correlations. We report our correlation coefficients and the corresponding p-values. So our R value, our correlation coefficient, and our p are significance values. And we do have significant correlations here. So we can reject our null hypothesis. We have this statement here, our null hypothesis was rejected. And if you have many correlations, you might consider putting your correlation coefficients in a table, like this excerpt from this table here. And now here are some an example of results that you might present for a regression analysis. So for regression, you first may want to present the results for your overall regression model, which would be in the form of an F-test. So again, for our F-test, we present our F value and our degrees of freedom. We present our P, or significance value, and our R squared value, which is the percentage of variance explained. Then if your regression is significant, you may want to present a table for your individual regression coefficients and explain any coefficients that turned out to be significant. So in this case, we have sex as a significant predictor in our regression. So that p-value for that variable was less than 0.05. And we just have an interpretation for that regression coefficient. And for the individual regression coefficients, you might present the B value, which is the unstandardized regression coefficient, standard error, the beta, which is the standardized regression coefficient, the T value, significance value, and here we have VIFs, or variance inflation factors, that you might present as well. So once you've covered the results for all of your research questions, you can then present a summary at the end of your chapter. So your summary, again, depending on what your school requires you to put into the summary, may summarize the entire chapter contents, or maybe you're just going to present a summary for each of the research questions and hypotheses. So there, you may just want to write a couple sentences saying what test was conducted for the research question, what the result of the test was, and again, restating the answer to the research question or hypothesis. So was the null hypothesis rejected or not? And then at the end of your summary, you may want to present a transitioning statement to your discussion chapter. And so that brings us to the end of the presentation on the components of the quantitative results chapter. Again, if you're interested in more one-on-one help outside of this webinar, you can use the information that you see here to get in touch with us and find out about the types of assistance that we provide. But now I'll go ahead and open things up for questions. So if you do have questions, you can feel free to type those into the question section, and I'll do my best to answer your questions. So looks like we do have one question put in already, and it is, what is a regression imputation? So that was mentioned earlier in terms of a way to handle missing data. So a regression imputation is basically just a general term referring to a way that you can replace missing values in a data set. What regression imputation will generally do is it will take the values that are available for a certain participant who may be missing some values and use their available values to try to predict what their answers or values would have been for the variables that they're missing. So let's say you've collected data on a number of different variables, like demographic variables like age, gender, ethnicity, things like that, and maybe some other variables of interest, but maybe they're missing a couple of those values for some of your research variables. So you might use the information that they have provided. So you might be able to take their age, gender, and ethnicity and use a regression imputation, and it will have an algorithm that uses that information to try to essentially predict or guess what their values for the missing variables would be. So that's just a form of imputation that allows you to replace missing values in your data set. So if anyone else has any other questions, feel free to put in those questions now. Okay, so one question is, how do you do regression analysis for predictors holding others constant? So when you do a regression analysis and you have multiple predictors in that regression, anything that you include in the regression as a predictor, you are essentially controlling for that variable. So in order to hold something constant or control for it, all you really have to do is include that as a predictor variable in the regression. So let's say you're doing a regression where you're trying to see if, self-esteem predicts something like leadership style, but you want to control for age, gender, ethnicity, or maybe some other demographic variables. Well, to control for those things, or in your words, holding them constant, you want to include those as predictors in the regression. So all you'd have to do is, in addition to your predictor of self-esteem, also include age, gender, and all those other demographic characteristics that you want to control for as predictors in the regression. And that will allow you to see if self-esteem is a significant predictor of leadership while controlling for those other variables. So it'll essentially tell you the relationship between self-esteem and your leadership outcome variable above and beyond what is explained by the other predictor variables in your regression model. All right, let's see. So I have another question. What is the best method of analysis for research on adolescent-friendly reproductive health services concerning modern contraception? and maybe antenatal care and skilled birth attendance as the outcome variables. So that would really depend on specifically what your variables are, what their level of measurement is, and that will really determine what is the most appropriate analysis for you to conduct on those variables. And we do have other webinars that discuss the topic of how to select the most appropriate analysis for your research question and your variables. So if you're interested in more guidance or more information specifically about what types of analyses are most appropriate for certain research questions or variables, I would direct you to the other webinars that we have on that specific topic. So another question is, if in doing regression, you get extremely large EXPB values, how do you explain it? So the EXPB would be your odds ratio. So if there are a number of reasons why you might get an extreme value for an odds ratio. First of all, it could have to do with just the scale of the variables that you are using. So if you're using predictor variables, for instance, that have an extremely large range of values, or can have extremely high or extremely low values, that will affect the values for your odds ratios, because the odds ratios just reflect the change in the odds of being a member of your predicted category based on a 1 unit change in your predictor variable. So a 1 unit change in your predictor variable can mean something very different depending on exactly what you're measuring. So that can contribute to very extreme values in your odds ratios. It could also be a reflection of sample size or separation in your data. So if you have variables that are too perfectly predicting your outcome, so if there's complete separation of your outcome by your predictor variables, that can cause some extreme values among your regression coefficients. And also, if you have a low sample size, that can affect your regression coefficients as well in terms of producing extreme values. So for an odds ratio, if the odds ratio is closer to 0, then that would indicate a lower probability of membership in a category. So kind of the baseline odds ratio would be a value of 1, which would mean that the odds of category membership are the same for a unit increase in your predictor variable. As values are greater than 1, then that would indicate that the odds of being in the category that you're trying to predict are increasing. If the values are decreasing lower than 1, it would mean that the odds of being in the predicted category are decreasing. But again, having extreme values for your odds ratios, whether they're extreme high values or extreme low values, could be dependent on any of those factors that I mentioned before. So another question is, if the variables are dichotomous in nature, will multinomial regression be appropriate for the analysis? So you could do a multinomial regression on that, but it might be simpler to do just a binary logistic regression, which really, if your outcome variable only has two categories or is dichotomous, then a multinomial regression and a binary logistic regression will essentially give you the same result. Another test that you could do with two dichotomous variables would be a chi-square test of independence. So that way you could see if the two dichotomous variables are dependent on one another, and you could use that with the chi-square test of independence. That would probably be the simplest analysis that you could do. If you had to do it in the framework of prediction, then doing something like a logistic regression, like a binary logistic regression or a multinomial logistic regression could also work. But like I said, we do have other webinars that are more dedicated towards discussion of selecting the appropriate statistical analyses based on things like your research questions, your variables, and things like that. So if you do have more questions about that, or you're interested in that topic, then you can check out those specific webinars. And this may have been mentioned in the chat before, but the recordings and the slides for this webinar will be made available after the webinar is over. So you should have access to the recording and the slides for this presentation. So if anyone else has any additional questions, you can go ahead and type those into the question section now. I'll just give about one more minute or so if anyone else has any additional questions. Okay, it doesn't look like any additional questions are coming in, so I'm going to go ahead and end the presentation for today. I'd like to thank everyone for attending today. And again, if you are interested in additional support, we do have other webinars covering other topics, and also you can use the information you see here to contact us if you would like more one-on-one support, outside of the webinars that we provide. So again, thanks everyone for attending today. I hope everyone found this useful, and I hope everyone has a great day and a great weekend.